Okay, so uh, we were told, that a piece of property is being subdivided into smaller lots, obviously to sell, right? And so the idea here is to, read the question, interpret what is happening here, and how do I come up with my inequalities really. So we determined that X would represent the number of basic cottages, right? And by the way, it's been taking me a little longer. I am about to return that last AC you submitted before going on break. The graphs is what I'm marking right now. So you will get that back probably tomorrow at some point. Okay, so number of basic cottages, Y represents the number of deluxe cottages. And so you get 1 mark for that. Write the constraints and inequalities of this problem. Really, constraints and inequalities are basically the same, right? It's a restriction, it's constraining the solution to just one section, right? And so what I will do here is to have enough room is this is your implicit constraint, right? That's always there. And my inequalities, there's a restriction on the number of cottages I can have, right? It's just up to 50 that I can have. So x plus y has to be less than or equal to 50, right? The number of cottages. And then there was a restriction on, that you only have this much available to spend. So knowing that the cost of a basic cottage is 15,000 and the cost of a deluxe cottage is 35,000, right? That combined has to be greater than, less than or equal to 1,050,000, right? Like those are the inequalities that are there. And then if you continue looking, right? So we've got the 15,000, 35,000. A lot of times the temptation, right, that you have to resist that is for students to somehow make up another one with those two remaining numbers. Okay, it's like, well, I have to, it's there, right? And there is no restriction, there's no requirement for profit. It's not saying you want to make at least a certain number of dollars. And the other one that is often being done by students that they'll just say, well, X is less than or equal to 20,000 and Y is less than or equal to 25,000. That way they somehow have easy inequalities that are easy to graph and they just plug them in, right? And it's not true because what does X represent? It's the number of cottages. So you're saying you have to have less than 20, less than or equal to 20,000 cottages. That doesn't make sense, right? So this is wrong to put that in. So don't make up inequalities that are not there. So we'll say 1 mark for this, 1 mark for that, and 1 mark for this. So that's where the 3 marks come from. Even though the constraint is I'm usually going to ask you for it here. So I'm going to make the assigning variables and the implicit all 1 mark usually. And then you can kind of tell that by the marks here that, it'll be 1 mark per inequality that appears, so that's also a bit of a hint. So keep that in mind. And so we have our two inequalities. We're supposed to graph it and label the solution region. For this first inequality, it's very easy to find my intercepts. And I will cheat a little bit. I will look at my answer key. Oftentimes I don't, so that I actually walk through all the steps. Okay, because every problem has some nuances that are unique. And if I just copy the answers, oftentimes you don't get all the little details there. But here, I will give you the x and y intercept. So the x-intercept here is 70, 0, because I know you know how to do that. That's why I'm able to do that. Most of you are really good at finding the x and the y-intercept, and you're very good at not mixing them up, right? Making the x-intercept appear on your y-axis, right? Like that's usually a problem. So we will call this basic cottages, number of, right? And this is number of deluxe cottages. And I will do the attendance yet. Don't worry about it, in case you're wondering. And so deluxe and basic, and I'm looking at my values here. I need to make sure I account for up to 70 along the x-axis. So I'm going to go 10, 20, 30, 40, 50, 60, 70, and for good measure, 80. Same here, 10, 20, 30, 40, 50, 60, 70, 80. Okay, label every second one. Okay, so there's my grid. I'm going to go 70, 0, and 0, 30. And I'm going to grab my ruler. Please use rulers for your graphs whenever you submit. Okay, and this is 15,000 x plus 35,000 y is less than or equal to 1,050,000. And then the other one is 50, 0, and 0, 50. And they're intersecting. So at this point, I just want to mention, you have a number of options for solution regions, right? You could have this triangle up here. You could have this polygon here. You could have that triangle there. Or you can, in fact, have all of this out here, okay? It is a possibility that everything above that is. If everything above this would be the solution region, then your corner points would be 1, 2, and 3, right? These 3 points surround it, and then it just goes to infinity, right? If you have this here, you have 3 corner points. Here you have 1, 2, 3, 4 corner points, and then if this were your solution region, then you have 3 as well. Okay, so keep that in mind. What I didn't do here is rewrite yet, so I'm going to do that. It's a little bit, so this tells you that below is true and that it's a solid line, and so if below is true, we shade above. But don't forget that this tells you where the true region is, okay? And this one rewritten, I will fast forward, and it is reduce -3 over 7x plus 30. Now, before you have a heart attack, you're like, I don't have that. This is probably the same. I just reduced it, okay? So if you get the same answer, then you'll be fine. So don't worry about it too much. I don't need you to reduce, okay? So again, solid, and I would say below is true, so shade above. And this is another thing, I'm going to pause here. Let me zoom out a bit. Okay, it should be consistent. So let's say you have 3 inequalities or 2. If you called it, right, like sometimes, you know, you have a brain fart, right? Like you just make a silly mistake. This is another thing to prevent you from making a mistake. If you have the same inequality pointing the same way, the shading should also be the same, right? Sometimes I see you they're not the same, and you can clearly tell that you're telling me they're both being shaded in the same pane. That doesn't make sense, right? So you need to watch out for that. Anyways, so let's go for the first. This one here was x plus y less than or equal to 50. So if you follow this line, everything above that is shaded, right? So I'm just going to follow it. and shade, and then you expand your shading, right? Okay, so that's taken care of. Then we follow the second line, and everything above that one is shaded as well. Is the false region, right? We're shading false because it's easier to then identify your true region, okay? We're getting rid of what's not a solution. So this is my solution region here. Okay, we need to label it. Label the corner of the solution region. So it's either you tell me what the corner points would be somewhere on the side, or you do it right on there. I personally prefer the corner points on the side because it's just, you know, easy to tell. So we've got 0, 0. We've got 0, 30. I'm just starting here, 0, 0, 0, 30. This one here, you need to use your calculator, and that one is 3515. Okay, this one is 3515. And then we have our last one, which you can just read, is 50, 0. Okay, so you've got 4 corner points here. So in fact, the 3 marks would be, you know, I would definitely give this one here would alone be worth half a mark, right? And then all the other ones, the 3 remaining would be half together, so to speak. And I would definitely, the solution would be half a mark. You graphing it properly with all the components there would be half a mark. So that like the graph itself would be 1, the corner points would be 1, and then this work here would be 1. I personally will be making it worth something like this would probably be worth more like 5 marks, but it doesn't really matter. It just translates, right? Like if it's worth 5 marks, then things that are normally worth half here would just be worth 1. So you're inflating the marks, but really, you know, 3 out of 5 or 6 out of 10, it's the same overall mark, right? So, but it's just easier for me to do full marks rather than half marks. So the graph is worth 3 marks. So that's where you go in, and like if the solution region is wrong, just because one of these you just didn't identify the proper above or below, but everything else is correct, I'll just take off half. But if your solution region is anywhere else, that means that you only have 3 corner points, then I would take off half a mark as well. Okay, so half a mark for wrong solution region and half a mark off for wrong corner points, or less work, right? Because of that. Okay. D is determine the value of the objective function at each corner point. So what's the objective function, right? Well, let's go back. The objective function is something that either tells you how to maximize or minimize something. And if you go all the way up to the question itself, if the developer wishes to maximize profit, there's that word. As soon as you're maximizing or minimizing, right, costs, you would want to minimize. That's when you're going to have an objective function somewhere, and it's usually towards the end. And that will allow you to find out, you know, come up with the best solution. So out of those 4 corner points, you're going to come up with the best solution. So I'm going to come up with the objective function first. You want to maximize profits. I'm going to call that capital P. Would be you profit 20 grand for every basic cottage, and you profit 25,000 for every deluxe. So this is the objective function, which is not an inequality. It should not show up. It's used after, once you've graphed, it's used then to answer that final question, that lurking question, which will maximize or minimize something, right? And so those numbers that at first we were tempted to somehow make it appear on the graph, sometimes they do, right? Sometimes, for example, I will twist this a little bit. If this question had said at the beginning, the developer wishes to minimize costs. Wait a minute, minimize costs. Okay. While those coefficients for cost, they show up here for this inequality, which has a restriction on how much can be spent. And it would then again show up here in your objective function, right? To determine finally which one of those corner points would minimize the cost overall. Okay, so sometimes it does happen that those coefficients appear under one of the inequalities and then again for your objective function. Okay, the objective function is here, and we're gonna plug in every single one of those corner points to give us the maximum. So you basically take 0, 0, which is pointless, but you still do that. Okay, so it's $0 profit. Then 0, 30, you plug that into your profit, which is, sorry, this is 0, right? Because x is 0, so that just turns into 0. So this is really 25,000 times 30, and we get an answer there. And then you plug in the next point, which is 3515. Plug that into your profit equation. So it's 35 plus 25,000 times 15. And then we'll do one more, the 50, 0, right? Plug that into the objective function. So it's 20,000 times 50. Okay. So there you have it. And when you run those through, you get 750,000 here. You get 1,075,000 here. And you get 1,000,000 exactly here. Okay. So out of all these options, this is the one that will maximize profit. So building 35 basic and 15 deluxe cottages will maximize profit. Oh, I just did something that it was supposed to go in here. State the optimal solution, right? Optimal, optimization, which is the best, right? In words, so that's what we did here. Building 35 and 15 in words goes there. So you get 1 mark for that. Okay. So what we're going to do is, this is going to be worth 10 marks, right? So at this point, it doesn't matter what you got. If you did extremely well, if you didn't do so well, that right now does not matter. So attendance is easy today. Everybody's here, so that's great. We are going to, I'm going to ask you to upload what you have right now. I just like to quickly glance through it and put a mark down out of 10. And let me just make that available to you. Okay, so there it is. I just made it available. So go ahead and upload your work there, and then we're going to continue with our next question. I'm basically going to do a bunch of optimization questions, and I still need you to be comfortable with simply graphing as a system that is non-contextual. No word problem associated with it. That's what it means. Stop this recording here.